Hello, am I audible? Okay, see, today there is a decision tree. We need to solve the problem using decision tree. But the thing is here, we need to calculate information gain also. This already I covered in the last class, but briefly I will explain and then move on to the examples. In the information gain, you can see that there is a formula of information gain. We already discussed the entropy. This entropy is measure the impurity. So in a problem, we are able to find the entropy of Y or weighted average of entropy, all these things. This is the information gain is entropy of Y minus weighted average of the entropy. This is the formula. In that, suppose population has 30 instances. In the total 30 instances, there is a somebody want to go to gym and somebody don't want to go to the gym. In that, 16 people go to gym and 14 people don't go to gym. Now we have two features. Predict whether he or she are going to gym or not. This is our problem. So suppose for before the main problems, just I'm explaining how this entropy and information gain, all these things is going to calculate. So for that, we can see here there is our problem is there is a 30 people are there, 16 people go to the gym and 14 people don't go to the gym. That's what they have. We have two features predict whether he or she will go to the gym or not. If new data comes, we need to identify based on the existing data set, we have to identify that. And that's what I already mentioned. Information gain measure the reduce the uncertainty given some features. So information gain will find the or reduce the uncertainty, whereas entropy is measure the impurity of the system data set. In that, there is a entropy of full data set. The entropy of the data is given some features. These are the some features. Now we can see feature one is energy, feature two is a motivation. Now here our intention is to find whether which one is going to be as a root
Sir,
node, because in a decision tree, as I mentioned in the earlier class, this is the root node. From that there is a branches will be like this. Mm, then we'll go to like this, and
sir,
finally it is in the tree shape. Once if it gets leaf node, we can stop it. So this is the way we are going to divide. And now in a features, a lot of features will be there, but which feature will consider as a root node? That is the question now. That we can able to find using the information gain. We can see here there is a root node. That root node may be energy, or you can see here this is energy I want to take, or maybe motivation. There is a two features let consider for understanding. One feature is energy, second feature is a motivation. So in the two features, which one we have to consider as a root node? Suppose if it is energy, again it is splitting as a energy is high and low. So suppose if I take energy is the root node, it is splitting as a high and low. This one is a high and this one is a low. So this is the energy if I take it. And other one if I take as a motivation, then you can see the motivation again, we have no motivation, and then one division. Suppose I will take as a motivation is a one root node. Then there is a three parts. This one, no motivation, then neutral, then high motivation, that is highly motivated. So these are the two things. And we are go on splitting actually, many number of features are there, but the question is here, which one, either energy I have to take it as a root node, or I have to take it as a motivation as a root node. For that we have to identify. Now, for that, what we are using as information gain formula, you have to use it. We have to decide either feature 1 as a root node or a feature 2 is a root node. Suppose feature 1 I will take and will calculate the information gain. Next part I will take it as a feature 2 and I will calculate as a information gain. So like that, feature 1 and feature 2 both we have to calculate. In a feature 1, they already divided in a problem itself. There is a energy is high, one division, energy is low is a another division. So here in energy is high case, again there is a two things. 12 members are energy is high case, it is a positive, will go to the gym, and one guy will not go to the gym. Normally, if the division is exactly correct, if it is a energy 16 members go to gym and 14 members are not going to gym, then the division will be directly like this. Actually, this will be 16, this will be 14. But there is impurity. We can see the division. In that, there is a, oh, hello, hello. Okay, ma'am. Just a minute. Oh, I didn't share the screen.
Yeah.
Then you will, why you are not informed so far, ma? Just a minute. Oh, God. I didn't share actually. Now it is visible. Check it
Yeah,
now.
sir. Yes, yes.
Visible, no?
It
Yeah,
is
yeah,
visible
it is
now,
visible.
sir.
It is visible now, ma? Anybody can answer? Somebody is responding.
Yes, sir. It's visible now.
Yeah, fine. Then you can drop down hand, ma. And that is one. And only two members are there. What about others? Yeah, so this is what so far I explained. I will briefly again once. There is a, we need to draw as a decision tree. In that one is the energy as a feature, another one is a motivation is a feature. In energy, again dividing as high and low. And motivation, again we have three classes there in that: no motivation, neutral, high motivation. Now what I will do is, which one I have to take as a root node to start the problem. For any decision tree problem, we have to start with the root node. In the many features are there, which one I have to take it as a root node. That is the decision factor here. For that, we are using as information gain formula. So for that, again, we need to calculate as entropy, and then weighted average entropy, subtract it, then we'll get it as information gain. That information gain will measure the reduction of the uncertainty. So uncertainty is here, which one I have to take it, that is only the uncertainty. In that case, what I want to do is, first I will consider as a energy and I will calculate the information gain. Then we'll move on to motivation. In that again we have to calculate the information gain, and which one is having the best one we can decide based on the information gain. So because it is reduce the uncertainty, no. And so once if we calculate the information gain, we can easily calculate decide either energy is a root node or motivation is a root node. Now we can consider as energy. Energy in that feature, what is the given is we are going to gym or not. It mentioned that 16 members are going to gym, 14 members are not. And whereas if energy is high, preferably they have to go to gym, or energy is low, they may not be. But in this, there is impurity is added. in the division, you can see even energy is high, only out of 16, they're going, only 12 members are going to gym and one is not going to gym, even energy is high. And energy is low, preferably they don't want to go to gym. Out of 14, 13 members are not going to gym and 4 members are going to gym. This is the situation if energy is a root node. Now we have to calculate what is the information gain. First, we have to calculate the entropy. Entropy of cases, you can observe that two features as I mentioned. In that two features, I already described this theory part. And two features in that first one I consider as energy. Now I have to calculate the entropy of the energy root node. So now in this case, parent node as a energy. In that positive entropy and negative entropy, two things will be there. The formula will be minus positive entropy log 2 positive entropy minus negative entropy log 2 probability, this one, and log 2 probability of negative entropy. In this, I already mentioned the formula minus P. This is the formula actually, minus P plus means positive probability log 2 positive. This one is a positive minus probability of negative and log 2 negative. This is the formula. So in that first root node you can consider. Which one is the positive entropy in this case? Let it be 16 are the positive probability and 14 is a negative probability. And total how many? 30. So therefore positive probability is 16 by 30. This one log 2 16 by 30 minus negative probability is 14. Then 14 by 30 log 2 14 by 30. So if I do that calculation, what is happening? I got 0.99. This we call it as a E parent or a first one, what you call it as a root node. That we will get it as a 0.99. Next, you can see entropy, energy is high, you have to calculate. Entropy, energy is low, you have to calculate. Now, entropy of parent means this energy. Root node, the energy is high case, with energy is high and with energy is low. And energy is high, what is the positive? 12 out of 13. So 12 by 13. And anyhow, this formula is log 12 by 13 minus energy is negative. How many you got? This is a 1 by 13. So now we'll get it as entropy with the energy is equal to high. You got it as a 0.39. And similarly, we calculate the entropy, energy is low. Same formula you can see. Energy is low. What will happen? Total is 4 is a positive values and 13 is a negative. Out of 13 plus 4, that is a 17. Now we can calculate entropy with root node. Energy is low. Energy is low. You can see positive is 4 out of 17. So 4 by 17. And negative is 13 out of 17. So 13 by 17. So now, if you do that calculation, we got it as a 0.79. This is the entropy we calculate. But what is our intention? You have to calculate the information gain. Information gain formula is information gain. I can write entropy of the parent node minus average or weighted sum of the entropy. This is the formula. Now we can see here, this is the parent, this is the weighted average you have to calculate. What before submitting the formula, first the information gain formula is the entropy of the parent minus weighted sum of the entropy. That's what our weighted average, I can say that. Now for that weighted average, what is the average here? Two things are there. When energy is high, you got entropy is 0.39. Energy is low, you got entropy is a 0.79. In the previous, you can see that. energy is low and high, we already calculated. High means 0.39, low means 0.79. You take this weighted average. So how will you get the weighted average? Using the formula, total is 13. You can see weighted average is this is the 13 in this case. This is 17 in this case. You multiplied with the entropy. When low is there and high is there, using that formula, you can see that 13 by 30 and 17 by 30. In that weighted average, when it is high, entropy is high is 0.39 we calculated. Entropy is low is 0.79 we calculated. Now we got it as a weighted average is this one, 0.62. Now we will substitute the formula. What is the formula? Information gain is equal to parent entropy minus weighted sum of the weighted average of entropy. Parent entropy we calculated here 0.99. This is the parent. You first calculate the parent, then the two features high and low here, high entropy and low entropy, you take it as a weighted average, and this value minus weighted average if you take, that will give as the information gain. That is simple formula. Now what I did is, this is the parent 0.99. Weighted average, we got it, energy is our root node. We got it as a 0.62. Therefore, we'll get information gain. Information gain is equal to 0.37. Now the question is, earlier the parent entropy was 0.99. After looking at this value of information gain, we can say that entropy of the data set will decrease by 0.37. Energy is our root node. Now we can see that instead of 0.99 entropy, the entropy is impurity. That's what now it is reduced. That means information gain, what it is doing here, the measure the impurity. So now it is reduced instead of 0.992, it is reduced to 0.37. This is the value of information gain if root node is energy. Now I calculated one part. What is second part? You can similarly, you can take it as a motivation. In a motivation is a root node. Then what is the information gain you can calculate, and you compare these two things and you decide which one is your root node. We'll see that part. So next feature is a, you can see that motivation. Again, as per the problem, motivation is divided into three categories. One is no motivation total. You can see that we're going to gym is a 16 members, is not interesting, will not go to gym is 14 members. In a 16 and 14 again divided based on their motivation. Somebody is motivated and they're going to gym. Now if no motivation, what is happening? Out of 16, only 7 members are going to gym during without motivation, and one is not going to gym. And similarly, some more neutral thing, some little bit motivation, then we can say that 4 members are going to gym and 6 members not going to gym. And highly motivated, if we do that, in this case, 5 members are going to gym and 7 members are not going to gym. Now we have to find the entropy of parent node. Same, earlier it was energy, we calculated the parent node entropy. And after that, we calculated the two entropies earlier. One is a high, energy is high, one entropy we calculated. Energy is low, we calculated one entropy. But now, same thing will repeat. 16 plus 14 out of 30. Positive entropy is 16 by 30. Negative entropy is nothing but a, whereas negative entropy is a 14 by 30. That's what we already calculated in the previous. From that, we got it as a 0.99, because there also 16 and 14 only going to gym and not going to gym. But only thing is root node is changed. Earlier root node is energy. Now you consider root node is a motivation. and we have to calculate the rest of the entropy. Now, first root node already calculated, we got 0.99. Now we'll go for as a entropy. Motivation is no motivation. How to calculate? Again, positive class, negative class, like that. Going to gym, not going to gym. The formula is again same formula, minus P positive probability into log 2 base, log 2 probability of positive class and minus negative class probability of negative. This one is a negative and log 2 same negative class, same formula. Now how to, it is very simple. By seeing here we can able to understand. Formula is minus sign A as such, and positive class is 7 out of 8. That's 7 plus 1 8, no, 7 by 8 log 2 and 7 by 8 minus. This is what we'll go for as a negative class. What is negative class? Only 1 is there. So that's why 1 by 8. That we got it as a point. This is a no motivation. No motivation means 0.54 is there. And then neutral motivation. Then out of 10, there is a 4 by 10 for positive class. Negative class 6 by 10. 6 by 10. We'll solve that. We'll get it as a, this is a neutral case, we'll get it as a 0.97. And last one, there is a highly motivated, the positive class is 5. That means 5 by 12 because total 12. No? So 5 by 12. Negative class is 7. 7 by 12. Then we get it as a 0.98. These are the, now we calculated the entropy. After that, what we need to calculate? We need to calculate information gain. So earlier information gain, if the energy is our root node, we got 0.37. But now we calculate the information gain. Before going to information gain formula, this is a parent minus weighted of entropy. So this we have to calculate. First we have to calculate the weighted average. How to calculate weighted average? That portion, what you call it as no motivation out of how many multiplied with this and multiplied with this. Next, highly motivated value multiplied with this. That will give as a weighted average. Now we can see what is the weighted average. See, there is a out of 30, no? Here total is 30. 16 plus 14 out of 30. How many no motivation and then how many neutral motivation? Here totally no motivation is 8 out of 30. This one is 30. Yes, you can say that 30. And this one is 80. This one is 10. This one is 12. Now individually we know the entropy value of no motivation entropy is this one and the neutral motivation is 10. And what you will do is simply you can 8, 10, 12 is there. So that you can multiply. So now 8 out of 30 it is 8. So 8 by 30. What you have to do? Multiplied with this value plus then this is 10. 10 by 30. Then multiplied with this value 12 by 30. This one multiplied with this value. That will give as a weighted average. Now we got it as a weighted average is 0.86. Weighted average is 0.86 if what is that? Emotion. That is what motivation. So motivation is your root node. Now we calculate the information gain. Information gain is equal to earlier parent node entropy is 0.99. This value is a 0.86. We can subtract. So now we'll go for 0.99 minus 0.86. We'll get it as an information gain value is 0.13. Now compare these two. What is previous? If energy is your root node, and then information gain is 0.37. Now what we can observe is the more reduction, which is 0.37 than the motivation feature. So then we can see that select the feature which is highest information gain and then split the nodes. So here what will happen, information gain is here 0.13, and whereas 13 is when it is a motivation is your root node, but whereas energy is your root node, information gain is 0.37. That's what we can able to find. So whenever the measure the impurity. So now if the information gain is 0.37 is the more value, then the root node is considered as a motivation. That is the reason we will select the feature which has the highest information gain. This is the formula we have to use it. So any problem, many number of features are there. What you have to do is, first you have to select which one you are going to take it as a root node. That selection is based on the information gain formula. If you want to calculate information gain of each feature and compare the value, which one is having highest value, that feature will take it as a root node and proceed for splitting and all. Now that is the conclusion in this case. Now energy will be our root node. Now we'll do the same for subnodes also. Now again, if energy is taken as a root node, another thing is what is our energy is high, energy is low. In the energy is high, again you want to split it. The splitting is leaf nodes and all. Then whether energy is high, you want to take it as a subnode, or low we want to take it as a subnode. For that also again you go for as information gain formula like that. That is the way we have to do. Finally, it has to reach the leaf node. We have to stop it. That is only the procedure for decision tree. Now we can see that when energy is high, entropy is low. Hence, we can say that a person will definitely go to the gym. So here, the difference between information gain value is high, you take it as a root node. That means entropy value is low. That's what the difference here. But what if the energy is low? Then will gain, that is will be gain split the node based on the new features. That is a motivation. There, if it is no, what will happen if it is energy? Then you divide two things. What is the two things? This is a energy. You are dividing. One is a high. This is a high. Then second one is a low. Then what you have to check it? If this is a low, energy is low. Again, you have to divide. This one is a motivation. This is a motivation. So motivation again, we are splitting. What we have to split? There is a three parts. So like that. So this is the way we are keep on splitting the thing. Now we can solve the problem. Example, just to understand, then we'll go for as a another problem as well. Only our intention to understand how to draw as a decision tree. Now, what is happening for the following data set? What is data color? There is a different colors, green, blue, red, something. And wing, there is a yes, no. Then ears, 2, and somewhere it is 3. Then what is your emotion output? So emotion is your sad or happy. These are the two emotions in the output side. May not be two, it may get anything also based on the data. Now we can see will be used to learn the decision tree for predicting whether the person is happy or sad based on color of the shoe. This is the color of the shoe and color of their shoes, whether they are wear a wing and number of years they have. So based on these features, we need to predict whether is person is a happy or a sad. That is what the emotion we have to detect. Now, what is our question here? what is the entropy if emotion with wing is S and emotion years are 3. So years are 3. What we need to find the entropy, and we need to find the entropy in the emotion is wing emotion with wing is S. So how many cases wing is S here? We can see one case here. Wing is yes, two cases. So now here for this, we have to find the emotion entropy if wing is yes. Similarly, you have to calculate the entropy if emotion years are 3. This only one option is there. Now for this case, we have to calculate the entropy. First, we'll see this one. Entropy, we have to calculate emotions with the wing is yes. So wing is yes, this is one row and another row is this one. These two I have to write it first. What I did is database wing is yes. I taken as a two cases. One is color is green. Wing is yes. Number of years are 2 and emotion is sad. And then color is red. Then wing is yes. Number of years are 3 and emotion is happy. So these are the table we redrawn from the previous, because in the first problem they asked emotion with wing is yes. What is your entropy? And in the emotion, entropy, emotions with the wing is yes. So wing is yes, two cases I told now. This is one and this is second one. These two write it separately. That is the first case I drawn separately. In that you have to take it as a entropy. What is the formula of entropy? Minus positive class probability log 2 positive class probability minus probability of negative class log 2 probability of negative class. That is log 2 probability of negative class. Now, what is the probability of this positive class? Here you can see that within the subset, we have one instant is sad, one instant is happy. Therefore, distribution of emotion is equal because the weightages are same. So one total is 2, no? So this is 1 by 2. Here what I can write minus 1 by 2. Positive class is total is 2, but what is the positive class? Let it be as a happy is a positive class 1 by 2 and log 2 1 by 2. This is the entropy formula minus this also negative class is 1 by 2. Then log 2 negative class is 1 by 2. And if we solve this, what we'll get is, you can see that this is the formula. Positive class or negative class, or you can say the two classes, sad and happy, anything. You can see like that. If you have many number, you can use this formula. Sum. Simply positive class or negative class or class 1, class 2 like that. So sad in that 0.5 log to 0.5 minus 0.5 log to 0.5. If I solve this, your entropy is 1. Now first problem, first bit is over. Entropy calculated. Emotions with wing is Y. S case, you got entropy is 1. Similarly, what I have to find next one? Entropy, emotion with years are 3. So in years are 3, only one case is instant. So years are 3, you write outside this and we'll calculate what is your information gain. And first, before that, you have to calculate the entropy. And in that case, what is happening? This is only one option is there with the years are, number of years are 3. Now we can calculate the entropy. what is the condition? Years are 3. We need to compute the distribution of emotion. Now, again, same formula, you have to use it. How many? Here only sad part is 0. Mean probability of sad is 0. That's why make it as a 0. And minus probability of happy. Happy is 1 out of 1 only. So therefore, 1 by 1 log to 1 by 1. Then this I can write it as entropy is a 0. Now, two cases entropy calculated. Given problem is this. So what we have to calculate is this is the entropy for this condition. If you want to calculate any other in exam, we may ask you instead of this question, exactly data set may be the same. What I will ask is calculate the entropy emotion with, instead of wing and ear, then color is equal to green. That's it. So color is green. What is the entropy? Anybody calculate and tell me the answer? How to calculate this? You can see very simple logic. The formula is fixed one. My question is here, you have to calculate entropy. Emotion with wing, I calculated the entropy value. With ear, C is equal to 3. I calculated the entropy value. Now my question is, entropy I have to calculate. Emotion with color is green. Color is green. We have to calculate the entropy. And color is green. How many? 1, 2, 3. This data you take it out. Now we have to calculate the positive entropy and positive class and negative class. All the three we are getting as a sad only. So according to this, what we have is, you can see that only one case is available, that is only the sad. This earlier it was 0, no sad, but only this is a happy is there 1, that is a 1 by 1. So now it will get it as a 3 by 3, that is equal to 1 only. So now we'll get it as a, your answer is 0 only. In the, if I change the question, entropy with entropy you have to calculate emotion with color is green, you'll get it as a entropy value is this one, 0 will get it. Like that, if any instant, if you want to calculate the entropy, that is the way we have to use, but that formula is this one in this case. No. Like that, we have to keep on doing how many features are there, or in that, you have to calculate the entropies. And if any 2 features are there, 2 feature entropy you have to calculate, and the weighted average you calculated and subtract the parent node with weighted average, and we'll finally get it as a, what is your, what you call it as there is a information gain. Once if you know the information gain, which is having as a highest information gain, that will become as a root node. Now we'll see when to stop the splitting. So like that, we are dividing. Suppose this is the thing, and one split is like this, then another split is like this, and it may be like this. So when, if it leads to leaf node, we have to stop it. Now this may be leaf node, and you can stop here, and this may be again splitting. This something will get, this may be leaf node, and you can stop this side, and again you want to get here, it may be coming like this, and then this may be leaf node. Like that, you have to keep on splitting the tree. So that, now how long we have to split the tree? That's what the question is here. When to stop splitting? There is a data set have a large number of features which will be result in a large number of splits. So as I said earlier, there is a 2 features. What is that? One is energy, another one is emotion. Or another example which we saw, one is a sad, another one is a happiness. Like that, it is only small example where the splits are very small. But if we go for real time or real world data, that will be as a huge number of data sets will be available. In that data set, we can able to split that many splittings, many main features are there, and start with the root node and go on splitting. While you are selecting root node, we will calculate information gain of all features, which one will get it as a least, that will consider. And again, you want to split for that two things, you have to calculate information gain, and which one is having highest, then we'll split like that. Take it as a sub node and layer splitting like that. So that is the point, which in turn gives the huge tree. Such tree can take time to build, can lead the overfitting, because it is many features are there, automatically it leads to the overfitting. The tree will give very good accuracy on the training data set, and whereas the testing side, it will be as a less accuracy. If it is overfitting, this word you remember many number of times, it will repeat. So overfitting means that it will perform well in the training data set, and then poor in the case of what we call it as a testing data set. That's what we call it as a overfitting. So in that case, there are many ways to tackle this problem through hyperparameters. So using hyperparameter tuning, we can able to overcome that overfitting as well. We can set the maximum depth of our decision tree using maximum depth parameter. So this is one more parameter we have to consider, how long we have to split is our decision tree. So in that case, you can observe there is a more the value of the maximum depth, then more complex your tree will be. So this maximum depth will be is less, means complexity will be less. Otherwise, there is a more value of maximum depth, then the more complex it will be the case. Then the training error will be of there is a decrease if we increase the maximum depth. So if you increase the maximum depth, then the training error will be decreases. But when our test data comes into the picture, we will get very bad accuracy. So that is the reason I'm telling that maximum depth value will be less. If it is more, then the more value of maximum depth, more complexity will be the tree, because we are splitting, up to leaf node, it will get it as more complexity. So that will not be overfit or as well as underfit our data. And for this, you can use grid search. This is the method we are using as a grid search method. We have to use it. So in this, we can see that minimum number of samples for each split is denoted by minimum sample split. And here we split the minimum number of samples required to do splitting. For example, the minimum of 10 samples of each decision we may be required. And then if nodes has less than 10 samples, nodes means that is whether it is a root node or maybe sub node and so on, going up to the leaf node. Using this parameter, we can stop further splitting of this node to make a leaf node. You can see the condition. Simply remember, if nodes have less than 10 samples using the parameter. So if the node is having 10 samples, that in that particular feature, if it is less than 10 samples, then using this parameter, we can stop further splitting the node. That is the condition. There are more hyperparameters such as mini sample leaf, we can use it, and another one max feature, you can use it. You can see the mini sample leaf represent the minimum number of sample required to be in the leaf node. Whereas the more you increase the number, the more in the over possibility of overfitting. Similar way, maximum feature, it helps us to decide what number of features to consider when looking for the best split. So this is what another maximum feature is. Let help us to decide what number of features. Let it be looking for as a best split. How many number of features you have to take it for the best split. Now we'll see the example. Chart algorithm we are using, classification and regression tree. This is the chart means classification and regression tree algorithm. So our intention is to classify for the new data set comes. Which class? Whether here you can see the target class is this one. Play is our target class. And how many classes we have? No is one class. S is another class. So in that target class, no and yes we have to divide in this manner. We can observe that outlook is now our decision is what, whether I have to go for play. It may be cricket or anything, tennis or whatever it may be. If the condition surrounding your condition is like this, whether we want to go or not, or play tennis or cricket or not. That's what. Using decision tree. And that means in a decision tree, chart algorithm is used. In that, outlook is sunny, then temperature is hot, humidity is high, the wind is not there, wind speed is maybe less or windy is false. Then whether you will play or not, as per the previous data set, you will not go for to ground. That is the first instant, or any other instant you can take it. Outlook is sunny and temperature is cold and humidity is normal and windy is false, then play is a yes. So like that, they have a input data or a data set. The question is like this. Now the new instance arise. You want to predict whether the candidate will play tennis or not, cricket or tennis or anything, just for based on the features. What is the feature here? Outlook is one feature, temperature is another feature, humidity and windy. Then target feature is what? Play. Play is our target feature. And these are the input feature. How many instances we have? This many instances. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So totally we have 14 instances. And how many features? 1, 2, 3, 4 features, input features, and one target feature is your output feature. So this is the given data set. Now the question is, you have to identify, your answer is yes or no, you have to tell based on your algorithm, decision tree algorithm. What is the sunny is your outlook, hot is temperature, you can see sunny, hot, and then humidity is normal. You can see sunny, hot, and then humidity is normal, whereas in this case humidity is high and windy is true, but whereas here false. If this is the case, I can say it is a no. But now, what are the conditions? Sunny, you have to take it wherever sunny is present with the hot and humidity is normal and windy is true. We have to identify whether we are going to play or not. That is the question. Now, as per our previous procedure, for the given play tennis data set, apply the decision tree algorithm, find the optimal decision tree, also predict the class label following example. This is the question. Now, first our intention to draw as a decision tree using this formula or using this algorithm. Now, in this case, there is attributes I already mentioned, 4 attributes or features. Attributes are outlook, temperature, humidity, windy. These are the attributes. Outlook, temperature, humidity, and windy. There are the 4 attributes. And one tag is a play. This is the output. So 4 attributes are the input and one is a call it as a output. And it is the binary classification because the target has two possibilities. Why I call it as a binary? It is a yes or no, true or false, 0 or 1. That is only your output attribute. So in a output attribute, we have only two possibilities. One is yes, another one is a no. So now what you have to do is we have to calculate this root node first. Now for that, you can see Outlook attribute I taken. In a Outlook attribute, what are the things are there? Outlook is sunny is one instant, overcast is another instant, rainy is another instant. That's it, 3. So in a Outlook, you take it as Outlook attribute. Again, possibility of sunny, possibility of overcast, and possibility of raining. So now you can see how many yes or no. That's all what is happening. Our target is yes or no only. No. In that case, first outlook is your attribute. Sunny. What is the probability of sunny time will go for play, or sunny time will not go for play, like that. So now you can see sun outlook is your attribute. Inside there is a overcast, sunny, rainy. How many overcasts are there? You can count the problem. Overcast, this is 1, 2, 3, 4. 4 overcast during outlook is, and overcast. Then sunny is 5 is there. Rainy is 5 instant. Now we can calculate the probability of yes and no. Now we can see if I copy this data set, it may be easy for you. I will show you again. See what is happening. There are 4 attributes. I will copy. Just a minute. This is our thing. And I will go here. So now we can see. It is easy now to understand the outlook. First I taken as an outlook. In that, how many classes are there? Sunny is one class, overcast is another class, and rainy 3. So that I wrote 3. One is overcast. Any order you can write sunny, rainy. And how many sunny is 1, 2, then 3, 4, then 5. So I made 5 is a sunny. And again, overcast how many? 1, 2, 3, 4. So 4 is overcast. And then rainy. This is a 1, 2, then 3, 4, 5. 5 is a rainy. These are the number based on the outlook. Now the question is probability I find play. If outlook is sunny, what is the probability of playing? No. And similarly, overcast, what is the probability of no and yes? Sunny case, no and yes. And overcast case, no and yes. Rainy case, no and yes. That probability you have to find. Now you can see how many yeses are there. Overcast means yes only one thing. I mean target. We are seeing as a target side. So sunny case, yes. How many? Sunny case, yes is 1. Another one, sunny, yes is 2. You write sunny, yes is 2. Then sunny, no. And here is 1. Sunny with no. Sunny with no, 2. And then sunny with no, 3. And this is yes. And this is yes. Yeah, we'll get it as a 3. Similarly, overcast, yes, 4, no zeros. And rainy, yes, 3, no 4s. Now we'll go for as a error, or you can say What is the error? You can notice Sunny is no. We can see that Sunny case total 5 is there, but no is 3 here, and yes is 2. What is error here? Sunny no I want. So that means error is two things. This also has to be like this, but there is error 2 will be here. That's why total is 5. And I'm asking Sunny is no. Why am this attribute is required? You can recall here Sunny is one outlook and hot. Temperature case is hot, humidity is normal, windy is true. Now I want to identify this combination. So now you can see that here outlook attribute sunny is no, overcast is yes, and rainy is yes. Then what is your error? So this thing we have to calculate. And similarly, this is what theory part I given to understand. Now we'll go for temperature. Same temperature, you can find temperature in the temperature. What is happening? Hot is one level and mild is another one. Cold is another. 3 are there. So now write a temperature attribute. Hot, mild, cold. How many number you can give it? Yes and no you can give it. Every case yes and no. Then temperature attribute, hot is no, mild is yes, cold is yes. This case, what is your error? This we are calculating from this data only. You can see that hot is no, hot is no, only 2 are there, but another error case SSR 2 are there. That's why 2 by 4 out of 4. And mild is yes. So mild is yes is 4, but error case is what? 2 is error, no? One is asking, the rest will be his error. The rest should not be. That must be 0 actually. But we are getting that also. So in that case, that I treated as an error. That's why 2 by 6 out of 6 we are getting as error is 2. And cool, no, yes. I'm asking cool is yes. Then 3. But error is 1. So 1 by 4. We'll write it as a 1 by 4. Like that, you can keep on calculating the total error. This is 2. This is 2, 4. This is 1, 5. So this is a 5 by 14. Why 14? 6 plus 4 plus 4. This is a 14. Similarly, you can go for as a, that's what I mentioned, Sunny is no, the best option here because 3 classes classified correctly and 2 classified incorrectly. That's the reason I consider that's what same even for Outlook case also. Sunny is no is your best option. Why not Sunny is yes? If somebody may get the doubt, why I'm not taking Sunny is yes, the best option. I taken as a here the temperature case, or maybe in the previous case also. I will move this. I will explain this part also. Now you can see. I taken. We need to identify one of these 4 attributes as a root node. So we have to find one of the 4 attributes is root node. What are the 4 attributes? These are the. Either I have to take it as a outlook is a root node, or temperature is a root node, or humidity is a root node. Like that, one of thing we want to draw as a root node. Next, we need to build a tree. In that now the question is attribute is selected as a root node. Which attribute? We will use some rules that generate as a minimum error. That is the attribute case. So in this minimum error we have to calculate. Which one is having as a minimum error? That will be as a attribute will be the root node. So attribute which generate the minimum error will be the considered as a root node. And rule is if I write overcast is yes. Overcast is yes. If I consider as a 1 split, 4 will be the classes correctly and 0 will be the incorrectly. See that if I take it as a overcast is yes, yes, 4 is correctly and 1 is incorrectly. That's why this is the attribute I consider the main case. Overcast is yes, I have to select. Similarly, you can see sunny. If I take yes, then what will happen? Only 2 are yes, but 3 are no. That means what I have to take? Sunny is no, I have to take. That's what I taken as a sunny is a no. Another one is rainy. Rainy, if I take yes, there is a 3 will be the yes and 2 will be the no. That's why rainy is a yes, I take it. These are the way we can decide the rules. You can see that if I write overcast is yes, 4 will be the correct and 0 will be the incorrect. That's why. And if I take overcast is no, what will happen? 0 will be the classified correct and 4 will be classified as a incorrect. So that is the reason I taken. So the better possible rule is what? Overcast is a yes. So first you have to decide the rule this set. How to decide this? Which one is having the more number in this classification? That is the best rule. So overcast is yes is best. Sunny is no is best. And rainy is yes is best. In that you calculate the error. Similarly, we can go for as a temperature case also. So sunny is no, then the best option because 3 will be classified correctly. That's what same explanation. And now we'll go for as a temperature and humidity and windy. So temperature, what is the best option? Now without this table, you are able to answer this rules. What is the rule? Hot. Which is the best? Because both is same, then you can take any one. Let it be as a temperature, no I taken. And mild, here is yes is the best option. And cool, what is the cooled is yes is best option. These are the rules, then find the error. Similarly, humidity. Humidity, high and normal, 2 classes are there. What is the best option? High is yes is a rule and normal is yes is a rule because maximum. Humidity case, yeah, no, it is S is 3 only. High is 3 yes case, but no is 4 case. Then high is no. Take it as a high is no. And then normal case, yes, you take it that error you got it. Similarly, wind case also you take it rules, got the error. Now we can see your attribute with error. So outlook, temperature, and madam. Madam. ఓ క్లాస్ ఓకే మేడం క్లాస్ జరుగుతుంది ఇంకా వదలలేదు జస్ట్ మినిట్ మేడం నేను టైం అయినట్టుంది పంపించేస్తాను ఓకే చూడలేదు ఓకే యా సో దెర్ ఈస్ ఏ టైమ్ ఓవర్ విల్ సీ ఇన్ ది నెక్స్ట్ క్లాస్ యూ కెన్ జాయిన్ టు మేడం క్లాస్ మేడం ఈస్ వెయిటింగ్ if you have any I will continue in the next class and then we'll start another if you have any doubt ask me then otherwise you can leave